Now statistics is very important chapter, and also your future is full of statistics. Okay. So there is also this data science, machine learning, it involves lot of statistics. Okay. So in fact in engineering also there is a new branch coming up based on statistics, which is mathematics and computing. Okay. So it is very important that you learn statistics well, and also from the future point of view. Okay. So what is statistics? So we have to start from the basics, and this is first time you are learning statistics probably in your life. So learn them correctly. Okay. So now imagine a data. Okay. So let's say there are some students who have written some exam. Okay. And they got some marks. Okay. So here I am going to explain you from the basics, but remember only once explanation is required, after that everything becomes clear. Okay. So let's say there are students here, I am naming the students as S1, S2, S3, S4, S5, S6, S7. Let's say there are 7 students and everybody got some marks. Okay. So let's say this guy got 10 marks, this got 15, 20, 40, okay, so 30, 10 and 5. Let's say marks are like this. Okay. And how do we find the average of all these? Okay. So how do we find the average? We take the total marks. Average is total marks divided by total number of students. Okay. So this is our basic logic of average. Okay. So we already know this idea. Okay. Now here when we look at this average, we are getting the total marks by adding them. So we can also call this as arithmetic average. Arithmetic means addition. Okay. Also we can call it as mean because it is average. Mean means average, but this is arithmetic mean because we are finding the average by adding them. If we find the average by multiplying them, then it becomes geometric mean, because geometric means multiplication, arithmetic means addition. Okay. So also sometimes to get the mean, we can also use other ideas like weighted means, okay, or root mean square. We can use many such ideas. Okay. So here mostly we use arithmetic mean, that means addition. Okay. So we also call this average as mean. Okay. So just give me a second. Okay. So what is the meaning of mean? It is average. Okay. Now let me use the standard terminology here. In general, we denote the marks with xi. Okay. So basically these are like x1, x2 till xn. Okay. Now we can say that the mean, which is represented with bar, okay, x bar is equal to sigma xi by total number of students. Okay. N stands for total number of students. I am using capital N here, but here I have used small n. So small n represents how many number of entries are there. Okay. Small n represents number of entries. Okay. Capital N represents total number of students. Number of students. So here I have taken a particular data and I am explaining. Okay. Now it so happens that n equal to n here, small n equal to capital N in this situation, but it is not always true. Okay. So let us take a different scenario. So here there were only 7 students, so I could make a table. What if there are 1000 students or 1 lakh students? Now how do I get the average then? Then making a table for 1 lakh entries is going to be a hectic task. So we will group the data. Okay. We will group the data by either numbers or by some intervals. Okay. So let us look at the grouped data. Okay. So here it is written as ungrouped. In some books it is written as grouped, in some books it is written as ungrouped. So this is a question mark. Okay. but you go by common sense, it is simple like that. So, let us say marks are here, okay. So, let us say there are marks like 1, 2, 3, 4, 5. Let us say I have taken and also 0, okay. So, erase all link 0, 1, 2, 3, 4, 5. Let us say I have taken a test for 5 marks only maximum, okay. And there are some number of students, okay, who come for this 0, okay. Let us say 5 students scored 0, 10 students scored 1, 20 students scored 2, 30 students scored 3, okay, and let us say 20 scored this and 5 scored 5 marks. So, if we have this kind of data, okay, so where for every mark we are taking the number of students who scored it. So, basically I have kind of grouped those many people into that segment of 0 score, okay. So, we are actually grouping the data here, we are not going by the students, this is called as grouped data, okay. So, now marks are still denoted with xi, but this number of students is denoted with fi, which also means frequency, okay. Frequency means how many times this reading is coming. Suppose let us say you are doing an experiment, and in the experiment these are the readings 0 to 5. So, here you are basically grouping them how many times that particular reading is coming. So, we call it frequency, okay. I hope this is clear, okay. So, now let us say if I want to take the average. So, what is the idea? Idea is still to go for the total number of marks divided by total number of students, okay. So, what is the total number of marks here? For example, if I take this mark 2, 2 is coming how many times? 20 times 2 is coming, because 20 students have scored the mark 2. So, that means I have to multiply 2 with 20. So, here basically we have to do, to get the mean, we have to do sigma fi into xi divided by sigma fi. Why do we have to do this? Because adding sigma fi will give us the total number of students, that is the denominator, and to get the total number of marks, we cannot just add the marks, we have to multiply every mark with its frequency, okay. So, that is how we got the mean here, this is the basic idea, okay. Now, there is also another type of group data, okay. So, here we actually group the total number, because if the even if total number of students is too huge, let us say we are dealing with 0 to 100 scale, then how to segregate the data? So, we do it like this 0 to 10, 10 to 20, 20 to 30, 30 to 35, 30 to 40 and 40 to 50. Let us say our exam is only for 50 marks, okay. And we have, this is still the frequency, we have F1, F2, F3, F4, F5, this is the frequency. So, here how do we get the average? So, here I am taking an interval. So, from 0 to 10 how many students have scored, okay. So, when I take this sigma fi xi divided by sigma fi, then basically the xi is the middle term of this interval, okay. So, from 0 to 10 what is the middle number? 5 is the middle number. So, here we have to take xi as, we have to take xi as 5 for this, 15 for this, 25 for this, 35 for this and 45 for this, okay. But now this is still an approximation, this is not exact, okay, because there might be students who have scored 0 mark, there could be students who have scored 1 mark, 2 mark, but still I am taking only the average value of that interval, but this is approximation, okay. So, in fact, the main idea of statistics is to go for approximation to save time, because when you are handling too much data, a million data, then you cannot go for the accurate, because computation will take longer time. So, we always go for approximation while compromising the value, but improvising the time taken for the calculation, okay. So, this way we can find the mean, okay. So, here I have explained what is mean for all of them, okay. So, for 3 cases, ungrouped data, and for group data of 2 types, I have explained how to calculate mean, what is the logic behind it. Now, let us accelerate and touch the other concepts, okay. So here we have understood what is mean. Okay. Now let us look at what is mode. Okay. So mode is the reading. Mode is the reading, that means here marks are the readings. Okay. Mode is the reading which is repeated most number of times, which is maximum scored. For example, if we go for the ungrouped data here, for this data mode is not defined. Okay. So for this there is no mode. Okay. Mode is defined only for the group data. Okay. So that means here mode is possible, which is the mark which is highest scored, which is scored by the maximum number of students. 3 is the highest mark which is scored maximum number of times, because 30 people are scoring 3 marks. So here in this particular case mode becomes 3. Okay. And what about here? Here I have not written frequencies. We can take another example. Okay. We have one more example here. Let us say in this table, what is the mode? Which is the reading which is scored maximum number of times. So here we are getting the maximum number. So what is the average value of this interval? 45. So here mode is 45. Okay. So mode is the number which is scored maximum number of times. Okay. Now let us say in an exam from 0 to 100, maximum number of students score 1 mark only. So 1 becomes the mode. Okay. So mode is the highest hit reading. Okay. Now let us look at the examples. Now there is again one more definition called as median. Okay. Now what is median? We will go to median after we understand what is variance and all that. Okay. So now let me look at this variance first. Okay. So here we got the average. Okay. Now from the average, if I take how much value is deviated for every reading. Okay. For example, for this reading for 20, I want to see how much variation is there from median, from the mean value to this value. Okay. So how much is he separated from the average value? Is he ahead or is he below, or is or how much is that quantity? Okay. So if you, this is called as the measure of dispersion. Okay. So how dispersed are the values from the mean position? If this is mean position, so how far it is going up and how far it is going down, that is called as measure of dispersion. How the values are dispersed, how the values are scattered. Okay. So that is always given by the reading minus the mean value, and we also take this as, after taking mode, we also take this as deviation. Okay. So let me just write it like this. Okay. So this is called as deviation. Okay. Now if I take modulus of this, it is called as absolute deviation. Okay. And if I take average of this absolute deviation, I will get the mean deviation. It is the average of the deviations. Okay. So mean deviation is nothing but sigma, we can also call this as a di, sigma di by total number of students in this case. But if we do the same thing for this case, so our mean deviation will become sigma, because for every reading we also have a frequency here. So sigma fi di divided by sigma fi. Okay. Now same definition is valid for this case also. Okay. So mean deviation must be calculated with this idea. Okay. So here the reason why I am explaining is, if you know the idea, then you do not have to remember the formula. That is how I also solve questions. In fact, statistics I only learned in my school, and after that I never even revised before teaching also, because it is very basic logic. Okay. If you know the logic, then you will remember it forever. Okay. Now that is how we calculate mean deviation. And then there is a new concept called as standard deviation. Standard deviation and mean deviation both are measures of dispersion only. These two represent how scattered are the values from the mean position. Okay. Now, standard deviation is RMS of deviation. RMS of deviation. So, what is RMS? Root of the mean of the squares. This is also a different way of finding the mean. Okay. So, this is root mean square. It is also a different way of finding the average. So, basically we are finding average of the deviations. So, how do we get it? It is root of the mean of the squares. So, squares of what? Of the deviation. So, I am basically squaring the deviation and I am taking mean of it, because every deviation is associated with a frequency. So, we write it like sigma fi di square by sigma fi. So, if I do this, I will get average of the squares of deviation, but by taking root here I am balancing the power. Okay. So, then this becomes my standard deviation, which is also called as sigma. Okay. Now, if we look at the earlier definition, earlier setup where ungrouped data is available. So, here basically sigma becomes root of sigma di square by n, because here frequency is not involved. Okay. So, this way we can find out the standard deviation. Okay. Now, if we take the square of the standard deviation, it becomes the variance. Okay. So, sigma square is basically variance. Okay. So, you already know this idea. Okay. So, here we have understood the basic terms of mean, mode and variance. Okay. So, here also for the variance it is the same formula. Okay. So, we have understood variance. Now, before we go for the median, let me just explain another formula for variance. Okay. Suppose we have group data. Let us say we have group data. So, that means x bar will be nothing but sigma fi xi divided by sigma fi. Okay. So, now let us say I am going for variance sigma square, that will be sigma fi di square by sigma fi, but di can be written as xi minus x bar whole square by sigma fi. Okay. So, here by simplifying and by expanding and also by applying this definition, we can prove that sigma square is nothing but sigma fi xi square by sigma fi minus x bar square. We can always prove it like this. Also, we can write this as average of the square, this is mean of the square minus square of the mean. We can always remember it like this. Okay. So, this is one simple idea to calculate the variance in terms of the squared terms and the square of the mean. Okay. So, here we have understood what is mean, mode and variance. Now, let us look at median. Okay. So, to solve for median, this is one simple tip to remember. Okay. So, that means if you know any two of them, you can find the other. Okay. So, if you know mode and if you know median, mean, you can calculate the median. But this will not give you accurate answer. This is an empirical result, statistical result, which is based on the experience and observations. You will not get exact value, but you will get approximate value. Now, let us look at median through an example. Okay. So, here I have put one example of the median. Okay. Okay. So, now let us solve this. Median is the reading which divides the entire population. So, here population is the students or the number of workers, okay, which divides the total number of data into exactly two halves. Okay. So, suppose let us say there are students who have attempted an exam from 0 to 100. Now there must be one mark, maybe it is 61 or 62 or maybe it is 43, any number. Now below which and above which we should get 50% of the data. Okay. So that means below that mark there should be 50% of the people, above that mark there should be 50% of the people. Okay. So it is the number, it is the reading which divides the entire population into exactly two halves. That is the definition of the median. Okay. So here how do we find the median? Okay. So to find the median we use an idea like this. Okay. So I can explain this using a different table here. So how many entries are here? 1, 2, 3, 4, 5, 6, 7. We got 7 entries. Okay. So let me take the data here. Okay. So here it is 10 to 20. Okay. So 20 to 30. Okay. So what is the average of these values? Average of 10 to 20 is 15. So let me take xi here. Okay. And 25, 35, 45, 55, 65, 75. Okay. And 4, 6, 10, 20, 10, 6, 4. 4, 6, 10, 20, 10, 6, 4. Okay. This is my frequency. Okay. Now we got the table. Okay. I want to find out the reading. What is reading? Reading is the xi. Okay. So also you remember that this is actually an interval. Okay. So this is from 10 to 20. This is 20 to 30. Okay. So like this. Okay. This is 30 to 40. Okay. So now this has actually confused you more. So I will take a separate column for xi. Okay. Okay, so 10 to 20, 20 to 30, 30 to 40. Okay, so in statistics it takes time because we are actually writing data. But if you are writing a program or something, then you will not take much time. Future is full of programs only. Okay. So now the xi is the average of these. Okay. So I am not writing xi, but that is fine. You know the idea. Okay. So now if I take the total, so here 20 is the highest reading. So 20 will give me the mode. So 45 is the mode here. Okay. So if you are interested in mode, we will get that as 45. If you are interested in mean, we can also calculate the mean, but here I am not doing that. I am only calculating median. Now to understand median, remember the definition. It is the a reading which divides the entire population into exactly two halves. Okay. So here let me calculate the total population. Okay. So what is the total population? To find the total population, let me go for cumulative frequency. It is also called as cumulative frequency, where we keep adding up the terms. So here we only have 4, add these 4 and 6, here we have 10. So that means till this stage, what is the cumulative? What is the total? Now till this stage the total is 20, till this stage total is 40, till this stage total is 50. So here 56, here 60. So we can say that the total number of people is 60. Okay. So now we have to find the reading which will divide this total population into exactly two halves. Okay. So what is the half of this n? Half of this n is 30. So we have to find out the reading of x, which is here, the reading of x, which will divide the entire population into two halves. Now check the possibility of coming. Okay. For example, let us say here till this step we got 20 reading. Okay. Okay. So let me just erase this. So till this step we got 20 reading, but after this step we got 40 reading, and if 30 comes, 30 must have come somewhere between this 20 and 40. Okay. Now check here, the interval, this interval has total reading as 20, okay, but we want how much? We want 30, okay. So, somewhere between 40 and 50 the median must be present, okay. So, that is the idea that we are deriving here, because from this step to this step, when we are going from this step to this step, we have just crossed 30. So, then that means somewhere between 40 and 50 the median must be there, one reading must be there where it is dividing the population into two halves. We have to identify that reading, but we have understood that it is somewhere between 40 and 50. So, how do we scale it? So, here is the idea. So, we know that it is somewhere between 40 and 50. Okay. See, here I am not using formula, I am using common sense. You can use this and solve the problems. Okay. So, 40 plus. Now, what is the total increment of the interval? Total increment is 20, and from 40 to 50, what is the increment? 10. So, 10 readings are leading to 20 increment. Okay. This is like 10 workers are giving 20 results. Okay. But how much increment do we want? Because we want the number 30, we want increment to be only 10 units. From this 20 reading, to get the 40 reading, we are taking how many? 10 steps. Now, how many steps do we need to reach the 30 reading? That is the scale that we are talking about. Okay. So, from 20 to 30, from 20 to 30, increment needed is 10 units. We are interested in only 10 units increment, but entire interval is giving me 20 units increment. So, that means we are going to scale this using this increment. So, out of 20 units increment, I want only 10 units increment. So, by using that fraction, I will divide this interval. Okay. So, what is the total length of the interval? Total length of the interval is 10 units. Okay. So, using this fraction, I will divide the length of the interval. Okay. I hope this is clear. So, here we can simply say that 10 units, here difference of 10 is giving me difference of 20. Okay. But I want increment to be 10, not 20. So, take the ratio of 10 by 20 and use this ratio to cut the interval which is of 10 units. Okay. So, here if I just simplify it, I will get the median, okay, which comes out to be 45 here. Okay. So, I hope this is clear. Okay. So, in general, to calculate median, we have to break that interval where we are just crossing the n by 2. Okay. So, this is all about scaling it. Okay. So, I hope you have understood the method. So, this is how we calculate the median. Okay. So, median is always the reading which will cut the entire population into exactly two halves. Okay. I hope this is clear. Okay. So, that is it, we have understood all basic concepts of mean, mode and median. Okay. So, you can always relate with this relation. If you know any two, you can also calculate the third. Okay. Okay. So, here we have understood what is the meaning of mean, mode, median and also variance. Now, let us solve some problems. Okay. So, here calculate the mean and standard deviation of the first 10 natural numbers. Okay. So, what is our reading? Okay. Our readings are xi are 1, 2, 3 till n. These are our xi. Okay. First 10 natural numbers. I want to find the mean. Okay. So, we can also take these numbers like this. Okay. As let us say reading 1, reading 2, reading 3, reading 4 till reading n. Okay. Now, how many total number of readings are there? N total number of readings are there. Okay. So, the mean will become sigma of xi divided by total number of readings. Okay. Now, this becomes n into n plus 1 by 2 because sum of n natural numbers is n into n plus 1 by 2, and it so happens that total number of readings is also n because I have taken only n numbers. So, luckily n gets cancelled. and we get n plus 1 by 2 as the average of all these n natural numbers. That is the mean. Okay. What about standard deviation? Standard deviation is nothing but sigma. Okay. But we have the formula that sigma square is going to be equal to, so I will just write the formula here. It is average of the squares minus square of the average, mean of the squares minus square of the mean. Okay. Now that means sigma square can be written like this, average of all squares. So it goes like sigma xi square divided by n minus x bar square. Okay. So we can write it like this. What is sum of all squares of n natural numbers? It is n into n plus 1 into 2n plus 1 by 6. Now how many total numbers are there? Total numbers are n only. So divide this with n minus, what is the average? Mean is n plus 1 by 2. So that is the average. So n plus 1 by 2 whole square. Okay. Now simplify this. Here we can get n cancelled and we can take n plus 1 by 2 common. So we will get 2n plus 1 by 3 minus n plus 1 by 2. Okay. So here we just have to cross multiply. 2 into 2 4n minus 3n, we are left with 1n, and 2 minus 3, it is minus 1. So we get n plus 1 by 2 into n minus 1 by 6, which is same as n square minus 1 by 12. So this becomes our variance. Okay. So standard deviation is the root of this. Okay. So SD is equal to root of n square minus 1 by 12. So this way we can calculate variance also. Okay. So once if the fund days are clear, then we can play with the formulae also. Okay. So can we move on to the next question now? Find the mean of the following data. Okay. So how do we find the mean? First we have to write xi by taking the average. Okay. So let me just remove this mode. So here it is between 10 and 20, average is 15. So here it is 25. Here it is 35, 45, 55, 65, 75. Okay. Now then how do we find the mean? Our x bar is going to be sigma fi xi divided by sigma fi. So this number of students is basically the frequency. Okay. So we have to find out fi xi to find the total summation. Okay. Because in the exam you don't have the calculator, so you have to learn this to learn to make a table for every value. Okay. So you have to make this a habit. Okay. So let me just multiply here, 15 into 2 30, 25 into 3 75. Okay. So 35 into 8 280. Okay. And 14 into 45 630. Okay. And 8 into 55 440. 65 into 3 195 and 150. So here we have to add all of them and divide with this sigma fi. Okay. So that way we can find the average. This is a simple question, finding the mean. So I am not solving this. Okay. Because we have a few more coming up. Okay. So generally questions on mean come very less, but questions on median and mode come, okay, more frequently. But mean and variance can be mixed. For example, the next question. Okay. So here mean and variance of 7 observations are 8 and 16 respectively. Okay. So what is mean? mean is basically x bar, it is 8, and the variance is given as already 16. So, if 5 of the observations are given, find the remaining 2 observations. This is easily mains level question. These kind of questions generally repeatedly come. Okay. So, you may find this question in this year's mains paper also. Okay. So, just prepare this well. Okay. So, here the readings are like this: 2, 4, 10, 12, 14, and let us say unknown numbers are A and B. Okay. Then how do we find the mean? Because this is a ungrouped data type. Okay. So, we just have to add all of them and divide with the total number. Okay. So, we can say that x bar is going to be equal to 2 plus 4 plus 10 plus 12 plus 14 plus A plus B divided by how many readings are there? Total 7 readings are there. So, 7, and x bar is given as already 8. So, 7 into 8 here, which is 56, is equal to, let us try to add them here. So, we have something like 6 here, 6 plus 14 is 20, and here we have 22. So, total 42 plus A plus B. So, from here we get a condition that A plus B must be 14. Okay. So, let us take this as equation number 1. So, here applied the information on mean. Now, let me apply the information on variance. Okay. So, we know the variance, let me do the rough work here. Variance is given as 16, correct? Yes. Now, we also understood this formula that it is the average of the squares minus square of the average. Okay. Now, average of squares can be calculated like this. It is 2 square plus 4 square plus 10 square, 12 square, 14 square. Okay. So, 10 square, 12 square, 14 square plus A square plus B square divided by how many total readings are there? 7 readings are there, minus what is the mean given? 8 is the mean given. So, minus 8 square. This must be equal to 16. This is the whole idea. Okay. So, now calculations have become strong now, okay, but we have to face it, we have to solve it. Okay. So, let us take 8 square here, 8 square is 64, 64 plus 16 will become 80, 80 into 7 equal to 2 square is 4 plus 16 plus 100 plus 144 plus 196, okay, plus A square plus B square. Okay. So, let me just add all of them. So, here we got 560. Okay. So, here combining these two we got 20. Now, combining these two we got 200 and 140, 340. 340 plus 20, 360 plus 100, 460. Okay. Plus A square plus B square. Okay. So, now this means we get a relation like A square plus B square is equal to how much? From 560 we have to subtract 460, which is 100. Okay. So, here we got another equation which is A square plus B square equal to 100. Okay. So, now think about the numbers. Now, just by looking at this number I am getting A and B to be 8 and 6. See, 8 plus 6 is 14, 8 square plus 6 square is 100. Okay. So, the missing readings are 8 and 6. Okay. But you can also solve them directly. Okay. So, you can use A plus B whole square here, get a relation for A into B and then put it there and get the answer. Okay. For example, we can do it like this, just for your clarity I am doing. So, A plus B whole square minus 2AB, A plus B whole square is how much? 14 square, okay, minus 2AB. So, from here we will get AB. So, 196 minus 100, it is 96, by 2 it is 48. Okay. So, now put this relation here, B equal to 48 by A and solve the quadratic, you will get the values. Okay. So, this way we can solve, but these kind of questions are very typical questions in main standard. Okay. So, now can we move on to the next question? Okay. So, calculate the median of the following data. This we have just solved. Okay. Okay. So, before we go to the logic, now let me take up another question. Okay. Because median is the most confusing aspect. So, I will take another question on median. Okay. Okay, so let me take the median here. Okay, so here if you check the cumulative frequency, okay, so I will also remove this. So this is my frequency, here I will take cumulative frequency, okay. So till here it is 5, here it is 15, here it is 35, here it is 65, here it is 85, it is 90. So there are total 90 students. Now total population is 90. I have to cut the population in exactly 2 halves. Okay. So if I take 90 by 2, it is 45. So my total n is 90. Now n by 2 is 45. Now I have to check where exactly this 45 is coming. So till here 35 and here 65, we have just crossed that number 45 between these two. So that means somewhere between 2 and 3 there is median. It could be 2 point something. Okay. So between 2 and 3 there must be median. So how do we identify that? So for that we do it like this. Median is equal to, it is above 2 of course, but less than 3. Okay. But when I go from 2 to 3, what is the increment here? What is the increment here? Increment is this number 30. Okay. So when I jump from 2 to 3, I am jumping 30 values. Okay. But I want to reach only 45, not 65. Okay. So increment is 30, but how much is the increment I want? From 45 to 35, what is the difference? It is only 10 values. I want only increment of 10 values, but here there is an increment of 30 values. Okay. So I scale the difference between 2 and 3 based on this scaling. Out of 30, I am taking only 10 units increment. So, and how much is the length of the interval? Difference is only 1 unit here into 1. So this will give me the median. Okay. So basically this difference which is between 2 and 3, 1 unit difference is there. I am scaling that 1 unit difference with the increment scaling. Okay. So this will now become 2 plus 10 by 30. Okay. So that is 1 by 3. So we got roughly 2.33. Okay. So this is my median. This way we can calculate the median. Okay. So I hope the ideas are clear. Okay. So this kind of group data and this kind of group data generally confuse you when it comes to median, but here I have explained the method. Okay. Now let me explain another concept of this statistics. Okay. So let me just remove this and explain another concept. Okay. Sometimes we also can get cases in probability. Okay. So in probability also this statistics may come. Okay. So now let me take an example and explain the aspects of statistics in probability. Okay. Now let me take one basic example of throwing a dice. Okay. So let's say I have thrown a dice. Okay. Now what are the possible outputs from 1 till 6? So let me take them as the readings. Okay. Now throwing dice is our experiment. Okay. Now in this experiment the possible readings are 1, 2, 3, 4, 5, 6. Now what is the frequency here? How many times 1 is coming? If it is already an observed data, we take the frequency, but this is not an observed data. we are thinking about an experiment. So, frequency must be replaced with probability. Okay. So, here Fi must not come, but Pi must come. What is Pi? Pi represents probability. Okay. So, what is the probability for 1? 1 by 6, for 2 1 by 6, for all these readings it is only 1 by 6. Now, this value does not matter, the concept matters. So, let us try to understand the concept here. So, suppose let us say here you want to find the average value that can come. So, generally by statistics we call it as mean. So, here x bar can be calculated as sigma pi into xi divided by sigma pi. Whatever are the concepts that we have learned in statistics, we have to replace Fi with Pi here. It is the same idea. Okay. But remember that in statistics we already have data in front of us and we are using that existing data. But when it comes to probability, it is the prediction. P, which is probability, also stands for prediction. Okay. So, here this is the predicted average, okay, also predicted mean. So, we name this as expected value. Okay. So, we also call it as EV, expected value, and in some books they also call it as expectance, okay, but it is the same thing. Now, if sum of all probabilities is 1, then we can also replace this sigma pi with 1. So, here when we throw a dice, there are only 6 possibilities. So, from 1 to 6, we will not get any other possibility. So, sigma pi must always be 1, okay, because there is no other possibility that dice has not fallen or it is not giving any output. So, it is not possible. So, sigma pi is 1, okay. So, we can also call this write this as sigma pi into xi. So, you might have seen this definition for expected value. Now, here I have explained the reason why this is happening. Okay. Now, if mean is defined, then median is also defined, mode is also defined, and variance and standard deviation are also defined. So, it is the same concept. Okay. So, for example, if I want, let us say, the variance, so how do we do that? We can go for xi bar whole square. Okay, this is a mistake. So, we can go for xi whole square bar. Okay, so, it is the bar of the mean of the average, mean of the squares. Next, it is square of the mean. We can use this formula and get it. Okay, but here x bar is basically the expected value. Okay. Now, this is one simple definition of the mixing probability with the statistics. Now, let me explain this expected value with one more example. Okay. Okay, so I will take this slide. Okay. Suppose let us say you have attempted one question. Okay, this is let us say mains paper example. Okay. Now, there is a question and there are 4 options A, B, C, D, and let us say marking scheme is +4 -1. This is the marking scheme. Now, you read the question, you do not have any idea of the question, you randomly guessed an answer. Okay, so, let us say you marked any option. What is the probability that it will be correct? 1 by 4, because out of these 4 only 1 is correct. Okay. So, if we make any guess, what is the probability that it is correct? 1 by 4. What is the probability that it is wrong? 3 by 4. Okay. So, this is our probability Pi. Now, what is the score you get? If it is correct, you will get 4 marks. Okay. If it is wrong, you will get -1 because there is negative marking involved. Now, based on this, what is your expected value, expected score? So, it will be sigma pi into xi. Now, denominator I am not writing because sigma pi is 1. Okay. So, let me just evaluate the expected score here. If it is correct, we will get 4 marks. If it is wrong, we will lose 1 mark. Now, what is the expected score? Expected score is 1 by 4 here. For every guess you are making in the exam, expected score is 1 by 4 for every question. Now, like this, how many questions are there? 90 questions are there. So, if you take expected score, okay, this is the expected average score, which is going to be 90 into 1 by 4. Okay. Now, check the value. How much will it turn out to be? If there are 90 questions. Okay. So, this will come out to be 22.5. Okay. So, this means in the earlier pattern when there are 30 questions per paper, even if you go for blind guessing, you must get 22.5 score, okay, because that is the average of the scores. Okay. Now, this does not mean that you go for blind guessing. Okay. So, this is just an analysis. Okay. But if we take +3 -1 scheme, average score will come out to be 0. Okay. So, this way also we can get the average prediction. Okay. Now, sometimes if you are, let us say, betting in a cricket match or something, okay, let us say India and Pakistan are playing a cricket match and you want to bet on India. Okay. So, if India wins, you gain something. If India loses, you lose some money. Okay. But there, how to make the decision whether to bet or not bet. Okay. So, if you want to bet, you want to be in profit. So, then the best technique should be to calculate expected value. If you calculate expected value and if your expected value is positive, then you can bet on it. Okay. So, if you are into the betting game, then make sure that you know about probability also to average out positive winnings. Okay. So, this is the idea of expected value. Okay. So, here we have understood what is expected value. Okay. Now, let me look at another idea here. So, the probabilities here are uniform, okay, because we have taken a dice, the probabilities are uniform. Okay. But if there is a different situation where these probabilities follow a pattern, then it is called as probability function because it is following a pattern. Okay. Now, if it is following a pattern and if this condition is also satisfied that sum of all probabilities is 1, then it is called as probability distribution. Okay. Probability distribution is basically a pattern of probabilities of the entire situation, including all readings, okay, of the entire situation where sum of all probabilities is 1. Okay. Now, if it follows a binomial pattern, it is called as binomial distribution. If it follows a different pattern, it is different distribution. Sometimes we may have linear distribution, we may have quadratic distribution. Okay. But probability distribution is actually a borderline concept. So, mostly questions do not come from that area, but I will take one basic example of explaining how the distribution look like. Okay. So, let me just erase everything here and explain the distribution. Let us say I have tossed 5 coins, okay, and coins are, let us say, fair coins. Now, I am considering how many total number of heads are possible. Okay. So, today I also skipped the doubt session, question and answer session, because there is too much to learn. Okay. So, stay with me. Here I am taking number of heads as my reading, which is xi. Okay. So, when I toss 5 coins, the total number of heads possible range from 0, 1, 2, 3 till 5, maximum 5 heads are only possible. Now, if I take the probabilities of all of them, so let us say there is pi here, Okay. So, what is the probability that we do not get any heads? It is phi c naught into 1 by 2 power 10. What is the probability that we get exactly one head? Phi c1 into 1 by 2 power 10. You know how to get this. Okay. This is phi c2 into 1 by 2 power 10. Okay. Because we took a fair coin. Suppose if I have taken one biased coin. Okay. Suppose if I have taken one biased coin, that means let us say probability of H is P. Then what about the probability here? Here we will get it as phi c2 into P square into 1 minus P whole cube. Okay. So, this is the binomial pattern. We can also get this number by Bernoulli's trials. So, here all general numbers look like this only. Okay. So, because the probability distribution is following the binomial pattern, we call this as binomial distribution. Okay. Now, here let us say if you want expected value, which is also same as the mean, then how do we do that? We should do it like sigma xi into pi divided by sigma pi, but sigma pi is 1 because when we throw 5 coins, then these are the only possibilities. Okay. So, adding all probabilities must give us 1 because there is no other possibility. So, we can just get it here. Okay. So, here it will come out to be sigma xi. So, we can take r going from 0 to n, but here we can take the n as phi. Okay. So, r going from 0 to phi into phi cr into p raised to r into 1 minus p raised to phi minus r. We can just find this summation to get the mean value. Okay. But if I take the fair coin, so I will do this only for the fair coin. Okay. For biased coin, we may have to expand this using binomial series, which is going to be longer task. So, that kind of question will not come. If question comes on this binomial distribution, then probably coins will be fair. Okay. So, for fair coin, expected value, which is also the mean, is going to be sigma r going from 0 to phi r into phi cr into 1 by 2 power 10. So, 1 by 2 power 10 can be taken common, and here sigma r into phi cr, you can find the summation. Okay. So, this is very standard, we can just differentiate and put x equal to 1. Okay. So, that means here when we take this 1 plus x whole power phi, which is phi c naught plus phi c1 into x plus phi c2 into x square and so on. So, here we can just differentiate with respect to x and put x equal to 1. So, we will get phi into 2 power phi minus 1. Okay. So, now just find out the value. Okay. So, here it comes out to be phi by, we are just taking out 2 power 4. So, this is 2 power 6. Okay. So, this is our expected average. Okay. This is the this is the expected value, that is right. Okay. So, this way we can calculate the expected value. Okay. So, but here the main essence of this problem is to show you what is the binomial distribution. Okay. So, now we will move on to the basic questions on logic. Okay. But before that, if you take the overall picture, we have two types of data, group data, ungrouped data. So, ungrouped data is not that important, group data is important. Okay. Now, if we take already existing data, it is the statistics. So, there we generally use the normal ideas, but if we are predicting, it is the probability. Okay. So, their probability distribution is involved, but concepts are same, they have common ideas in both of them.